Hi, everybody. So what's the topic today? I hope you are not too tired. Welcome to, of course, to everybody in presence and online as well. So topic is going to be using basically the cloud and the containers, and we will see also container orchestrators to scale, so to help you, let's say, build and scale a startup. I guess most of you are really interested about that. Just, I don't want to be boring, so I'm basically a software and DevOps engineer, more or less 10 years of experience. So I started working, studying, working in Switzerland. Then I came back to Italy. And now I'm working as a freelance consultant mainly for Red Hat, which was also my former employee. And also I have several customers, let's say mainly in Europe. And I'm doing consulting as well as trainings. So this is okay. The title is in Italian, but don't worry. It's just to tell you, I also produce online courses, and this is the first one I launched, which is Kubernetes for developers, and this is in Italian. More courses are coming soon in English. And one new, let's say, project of mine, so I published also a book, and I encourage you to stay till the end. There's gonna be a surprise about that. Let's start. So, I would like to ask you a question. So what is a startup for you? So I ask maybe the people here.
Correct.
Yeah, I think so. I think you defined the startup better than I could, of course. And so basically, this is exactly something like this. In my opinion, it's an early stage of basically of a company founded by entrepreneurs, which are building, of course, a product. It's, of course, a business model for, let's say, publishing your product, your services. And what are the challenges for a startup? In my opinion, at least, this is an environment which needs to be really flexible, okay? So basically need to be agile, change the course, change your direction quickly and multiple times, mostly. You are evolving really fast. We are in a dynamic market, so we need, okay? We might, little bit of echo, no problem. Basically, we can scale up. We can even periods, scale down, and maybe we keep growing again. It's not, of course, some kind of linear function. So, and basically, it's related also to the technology. It's harder to have big upfront investments. Not all of us, let's say, not all the contexts are blessed by having a huge amount of money since the beginning. And let's say from the technical point of view, of course, which is my background. So how did, let's say, look like creating a startup a few decades ago? In terms of IT, you needed to invest a lot of money. Okay, because you need to buy infrastructure, you need to buy server, you need to connect those servers with the network. You need maybe to rent some place to place this infrastructure or even buying the place. You need software licenses and more because sometimes you need to invest also money, let's say most of the time, also maintaining this infrastructure. So it's not easy. Well, it was not easy because now we go to, let's say, to the present, 2022. So what is the cloud? So the cloud defined, let's say, in a simple way, it's what you see now in the slides. This is the cloud. So you have infrastructure in data centers, okay? You have machines, huge amount of machines, of course, thousands, millions of machines connected together with the network, okay? On top of them, we have some special software. We virtualize everything and we provide a service as a single entity. So we interact with the cloud as a single entity, but after all, it's just a network of machines, which is provided to us like as a single consistent service. And let's say there are different usage models for the cloud. The one we are starting with and the one which, let's say, we talk about at the beginning today, it's the infrastructure as a service, so model. So we have infrastructure, let's say servers, basically computing power and storage, which are provided to us as a single entity. So we don't see this big network, let's say, of machines. No, we just open maybe the web browser and we say, I want a machine. I want some storage space. That's it. I want to put my file, let's say, in the iCloud in Google Drive. So this is infrastructure as a service, okay? And how infrastructure as a service helps scaling a startup. So what are the advantages? Let me go through a short list. So first of all, we said big upfront investment. We don't want to buy infrastructure. And this is super nice, in my opinion, because with the cloud, you just open your, let's say, your web browser or even an app, actually nowadays, and you can spin up 10, 100 machines in the cloud. You can spin up storage space to put your images, your videos, okay? This is done in a few minutes, which is awesome. So you provision everything in a few minutes. It's not, you know, you have big process to order machines, then they have to be delivered. Maybe, you know, some pandemic is hitting the world and then your servers are not arriving. With the cloud, you know, you just open your web browser, let's say, and you can click and spin up virtual machines, or even better, you use automation. You use some system, some scripting system to spin up infrastructure. And this is done within a few minutes. So you also, let's say, don't need big sizing considerations. Because imagine if you are buying infrastructure, you might need to know, do I need 10, 50, or 500 machines? With the cloud, you can start maybe with 5, with 50, then maybe you scale up or scale down in a few minutes. So I think this is awesome. Scalability, of course, it's really important. So as we noticed, we can always add more machines. Or in case we are, let's say, in some phase in which we are struggling in our startup, we can reduce, let's say, the infrastructure, okay, in terms of CPUs, in terms of memory, disks. And then maybe we solve our challenge, let's say, and then we can scale up again. Let's say we can start spinning up new machines. Maybe we just needed 100 gigabytes of memory and now we need 1 petabyte. We can do that. So we can scale in an elastic way. Now, in terms of reliability, I think it's really interesting as well because it's easy to build a redundancy. So we can spin up, let's say, infrastructure, CPU, memory, disk space, and this can be done in a redundant way. So in the cloud, you can specify zones and you can specify regions. So you can spin up a disk, let's say, which is, I don't know, let's say in the region of Google Cloud in Germany, for instance, and you have 3 different data centers, 3 different zones. So if one starts burning up, let's say, which is something that sometimes happens. I think you have heard probably the OVH company in France, which had a major accident, for instance. So, but if you're using multiple zones, even if one zone, one data center is disconnected by the network, you can still, provide your services in an available way. And this is the trick which is doing, let's say, which is used by Netflix, for instance. Netflix is using 3 zones, 2 in the US and 1 in Ireland. And they even, let's say, disconnect 1 data center every month to test if they can still provide, let's say, streaming services. So reliability, of course, it's a much harder. Imagine if you are buying servers, physical infrastructure, you need to install it in different cities, connect to a reliable and fast network. Everything is provided, let's say, not for free, of course, but with a reasonable price for us in the cloud, let's say by Amazon, by Google, by Microsoft, which they know what they are doing. They are in the business, and of course, they are, let's say, they can exploit, they can use economy of scale, okay, to provide a nice price for us. Of course, reliability is also in terms of data. So we can have our data replicated in different regions. For instance, we have a copy in the US, a copy in, I don't know, in Asia. And if we have some trouble, let's say, in the European data center, we can still recover our data because they are replicated and backed up in China as well. So, which is super handy. We can, of course, use this, let's say, global scale, not only for resiliency, of course, but also to improve performance. Because, I mean, of course, we have the limit of physics, which is the speed of light, but, and also the bandwidth and the load on the infrastructure. So normally, if, let's say, if you're accessing a video, it's better if the video is streamed to you to the closest point of presence. So if you stream a video which is coming, let's say, from Hong Kong, or if you're streaming a video which is coming from Madrid, it's different. First of all, because of the speed of light, but secondly, also because, let's say, we could go through maybe some overloaded routers through the way, let's say, from Asia. Okay, so it's the speed of light is the theoretical limit, but actually we never hit, let's say, the speed of light because we hit first the maximum load we can have on machines. So that's why, let's say, in services like Netflix, they are installing and bringing the video close to our homes, okay? Close to our homes so that we stream just for the last miles, let's say, for the last few kilometers. And you can do that in the cloud. Imagine if we have to build that alone and we are in a startup, we are in a rush, we need to be fast, we don't have that much of money, we might fail, okay? So we need to, let's say, if we invest a lot of money, that's not great. Or maybe we are super successful and we need to scale so fast. This is possible through the cloud. Yes. I will repeat the question because I don't know if the online people could hear it. So the question was basically how, let's say, how do we actually configure? How do we actually, let's say, realize we are replicating data and we are being reliable? Of course, so the answer is, so of course we need to be aware of that and we need to configure our infrastructure to be resilient. You need to be aware. So basically, let's say when you are building a cluster of several machines, let's say you have 10 machines or let's say 9 machines, and maybe you want 3 machines in Spain, 3 machines in Germany, and 3 machines in the UK, for instance. So you need to configure that, of course. And it's actually super easy. So especially developers, I am also. So we love experimenting, okay? We love experimenting, and I mean, it's curiosity, but it's also a matter of, let's say, helping a business, okay? It's not just about, nerds experimenting. Sometimes it is. We need we need a special, let's say, analytics database, which has been released by Google maybe. And we want to experiment if it can help our business, okay? Maybe we test it and we say, no. We test, let's say, this brand new technology, and maybe we realize, wow, it could save, let's say, a lot of money, a lot of time. We can use that. So you just, provide a server with a few clicks or maybe a small script, and that's it. You pay, let's say, for what you used, maybe a couple of euros or 10 euros for the usage, and then you decide, in case it has been useful, you can move forward. In case it was not useful, you just delete it. You invested, let's say, maybe 10 euros, which could be a reasonable cost. I think this is also nice. And I loved it also when I was, let's say, in some companies. I could experiment with, new technology. That's something that makes me really enthusiastic. So now we have, let's say, we have talked about the model of infrastructure provided by the cloud to help, let's say, our startup, which is awesome. This is one model, let's say, of cloud usage. This is the first and, let's say, the most low level, let's call it in this way. So we are still thinking in terms of processing power, in terms of gigabytes, let's say, of disks, okay? And what happens when a startup, which I have seen, let's say, in a few also other customers, what happens when we are getting bigger, which is nice. If we have a startup and we have a lot of customers, it means we are successful. And maybe, we started with just 2 or 3 developers, and let's say, then we have 10, 20 developers, some product, maybe one product, owner, and some people which is taking care of the financial part. So when you start reaching, let's say, this level and your startup is successful, of course, you realize that you have many applications. So you realize that you started maybe with 1 or 2, and then you end up, let's say, with tens of applications. And it starts getting difficult, to handle all these applications, to handle the life cycle and the deployment and running them in the cloud. What are normally the challenges I have seen? So as we said, we are building application from code, and let's say building an executable, something that can run on a machine. So we need to place this application on several machines. Imagine when you have like 10, 20 applications, and each application need to be installed in 50 machines. I mean, it starts getting difficult, for maybe just a few people, and not, without something more that can help you. We also need to make our applications portable. Portable means that I can take my application, run it on my laptop. I can take the application and run it on Google Cloud. I can take the application and run it on AWS. Okay, it shouldn't matter where and how I'm running. Our focus is to have a successful startup. So the idea is like to be less dependent from the technical details. And also, of course, we don't want to be locked in just maybe with a provider, because if we are using AWS and one day the managers, they decide to double the price, what do? Maybe you need to migrate, let's say, to another cloud. But your, let's say, applications have been designed for AWS. And then you are a bit in trouble. Of course, you can change, but it needs some time. And we said at the beginning, in a startup, it's better to be as fast as possible. And vendor locking, I mean, it's something that also we have to keep in mind. So the cloud webs, I think we all agree by now that is amazing. It's, of course, it's not for free, has some price, but nothing is for free. So it's always about trade-offs. And in my opinion, this is a good advantage we have. And we said infrastructure as a service is actually a low-level abstraction. It's too, let's say, technical. And what do we need? We need something on a higher level. We need to be more flexible. And if we check, let's say, on this slide, we are basically at the bottom of this, let's say, pyramid. We have infrastructure, as a service. I took it from this source, so in case you are interested later, I will share, of course, the slides, and you can also access the picture. And I will share the slides by a link, so don't worry. And as I said, we are in the pyramid at the bottom, okay? We need to go a bit, let's say, towards the top. And the step we need now, it's normally called CaaS. So some people says container as a service. Some other people like me says container orchestrator as a service. It does not really matter, We just need to know that we are going to an high level abstraction, that is also understandable and usable, let's say, by people which is not, the super expert in software engineering. So we need to go to a high level abstraction. And the idea now, what if we take our application, we package it in a nice portable way, and we deliver it to some kind of tool? We don't care if it's running on AWS infrastructure. We don't care if it's running on Google Cloud infrastructure. I just want, or even imagine, can even run on a Raspberry Pi, let's say, so which is a super portable device, with a ARM architecture. So it could be even, a nerdy experiment we are running in some infrastructure in our home. So we need to be flexible, we need to be portable. And I want to deliver applications without thinking so much, So basically, let's think about this nice picture. This nice picture is the commercial harbor in Rio, in Brazil. We see really nice weather. And what do we see also? We see a lot of containers, of course, physical containers with goods. And we see also some infrastructure, which is orchestrating, which is managing, moving them, loading ships, unloading ships, transporting them. So we need something like this, basically. So the physical containers are, let's say, our executable applications, which need to run to provide a service, our startup, let's say. And we need to move them. We need some kind of tooling. Otherwise, it's difficult to handle all these applications. Maybe here we see hundreds of applications, let's say. We see hundreds of containers. We need something like this, This is a nice image, which is in the documentation Google Cloud. And what do we see? If we start on the left-hand side, this is exactly what we need. Let's say if we are a startup after an initial phase, when we are starting seeing success. We have our developers on the left, the blue, let's say, people. And they need just some kind of infrastructure, some kind of tool, let's say, to interact with. They interact through the red middle, let's say, piece, which is an application programming interface. And they just interact using APIs, okay? And they say, I want to run my application number 1, 2, 3. I want to run them. I don't care how, where. I just want to run it. And I want to provide a service to the world. I need to, show my service to the world and convince them that it's nice and to use maybe my service and pay for it. We don't care about, providing all the infrastructure, being reliable. Of course, this is going to be done anyway, but this is done by a tool. This is, hidden from us. This is Kubernetes, basically. So Kubernetes is the most common, the most popular container orchestrator. So a container, think about a container if you don't know what it is. like an application, an application packaged in a nice portable way. And you have the application packaged, you just, deliver it, you just deliver it to Kubernetes and say, run it in a reliable way. I don't care. This is basically what Kubernetes is doing. So it's running application for us. We just build an application and deliver it to Kubernetes and say, run it. That's it. So as we notice, we are not thinking about CPUs and storage and everything and machines, and networking among machines. We're just thinking about our application, which needs to run and satisfy our customers. So we are abstracting, the infrastructure. I call Kubernetes as the operating system of the cloud. If you have your laptop, you have, let's say, Windows, you have Ubuntu Linux, you have maybe Mac OS, And when you are opening, let's say, your web browser, your email application, Photoshop or something, you are not thinking about how this is running on the physically in CPU. You are not thinking about how the memory is allocated. You are using just, your application. And this is what Kubernetes is doing with the cloud. You install it and you say, I want to run my services to provide a nice, service to my customers. And I don't care about the infrastructure. Could be on Amazon, could be on Google Cloud, could be redundant for resiliency, could not. I don't care. Of course, you just need a few configuration parameters, but you don't go low level. Maybe you have one or two experts in your startup which know also the underlying details. But let's say maybe you are more in the technical sales, or let's say you are maybe a solution architect, or you are the CTO, which does not need to know, the CPU model running your application. Just needs to have an understanding, of course, how everything is working, how everything is connected. So Kubernetes is a container orchestrator, so handles applications, placing them on the infrastructure. So Kubernetes is smart enough and basically can place our applications on the infrastructure close to you, and also to infrastructure which is not so loaded. So you just say, run the application. And then Kubernetes is taking care of running the application close to your home. And also, let's say, keep it running, keep it resilient. The application could have bugs, could crash. Kubernetes is restarting it, let's say. Or maybe your application needs has at the beginning 100 users. Then you are super successful after a campaign on social media. And from 100, you just scale up, let's say, to maybe 50,000. This is what happened actually in the past with Pokemon Go. You remember probably the game Pokemon Go, and it was designed, I don't remember for how many users, but let's just make an example. It was, let's say, designed for 1 million users. And what happened? The people was so happy and so enthusiastic about this game that within a day, they actually had 100 times the traffic they expected. Pokemon Go in the backend was running on Kubernetes, on Google Cloud. And they struggled a little bit at the beginning, but within, let's say, a couple of days, they could go from, let's say, 1 million to 100 million users. So they could scale that fast thanks to technologies. Of course, it was not the only one, but the main one was Kubernetes, which is amazing, I guess. If, let's say, we launched Pokemon Go, let's say, before the existence of Kubernetes, probably Pokemon Go would have just crashed, and would have been unusable after maybe a couple of days. So I think this is really amazing for scaling, as well as we said, failure recovery and allocating the applications in an intelligent way. Let me see, what time is it? So yeah, we have still some minutes. Now let's let's now then, since we have, let's say, almost 10 minutes for the presentation, and then we have, of course, questions. We have a bit of time for some, let's say, some animations which are explaining better what Kubernetes is doing. We are talking about allocating applications to machines. And in these slides, you see a bunch of servers. Of course, this is, I mean, remember, Kubernetes is abstracting this from us. Okay, so we don't really care. But just to understand it better, what is happening under the hood, let's say we have an application which we need to run. And we need to allocate this application. So I'm a developer, you know, I'm in a team, I have my product owner, which is asking the developer team to bring this feature to the client, you know, so that they can use it. We develop an application and we say to Kubernetes, run it. Kubernetes, let's see, yeah, it plays the application on the machine one. Why? Because probably the machine one is close to the user, probably because the machine one has a lot of, you know, CPU and memory. Maybe the machine 2 and 3, they were struggling. Maybe they were running already other applications, and it's better to run on machine 1. So from our perspective, we say run the application. Kubernetes then is doing all the magic, you know, and let's say running it on machine 1. But if you're a developer or a product owner, let's say in a startup, you don't care that you are actually using the machine 1. If machine 1 goes down, Kubernetes is moving, let's say, the application to machine 2. So we are not so interested that machine 1 was down, you know. Machine 1 eventually is going to be also automatically replaced, also by the intelligence, by the automation. So this is like the operating system. Let's say we have an application and you see the number 3 on the left-hand side. Our application before, let's say, we have our green box running on machine 1. But actually, probably our application under the hood has 3 instances. So 3 executables running, let's say, because we want to handle more traffic. So of course, just one cannot keep up. So we need 1, 2, and 3. Same application running with 3 replicas. Tomorrow is the Black Friday, let's say. And we know, since we are developing a new e-commerce startup, that tomorrow, let's say, or in a few days, we have the Black Friday. So we need to scale a little bit up because for sure, we're going to have more traffic. And we don't want to crash exactly on the Black Friday, which sadly, some companies, you know, you have seen that some companies are struggling. And I had exactly this use case a few years ago when I was working in an e-commerce company in Switzerland. We needed to scale like exactly in this way before the Black Friday. So let's say now we increase the capacity, okay? And we go from 1, 2, or 3 replicas, we go to 4, to 5, to whatever we need. And in the slide, you see we had 3. And now I just say, I want 4. Or maybe I can even better. I want to say to Kubernetes, I don't care, just provide how many as you need. And Kubernetes is spinning up or down, let's say, like the breathing, you know? So you inflate, you deflate, you know? This is handled by Kubernetes. Another use case, applications, I mean, we make mistakes. I made mistakes also while developing. Sometimes, you know, I introduced some nice features. Sometimes I introduced also bugs and the application maybe crashed. And you see on this slide, one application is having problems. Number 4 is having problems. So it's not working well. Kubernetes just ignores it for a while and is using, let's say, the other applications which are working properly. Now, Kubernetes, our orchestrator, restarts the application and, of course, hopes it helps. Luckily, in this case, helped. So, of course, we need some mechanism to let's say, to notify the developers that something like this happens, because Kubernetes helps us to scale, helps us to be resilient, but of course cannot solve the bug. This is, of course, just a human can solve the bug. So we need, of course, now to notify this situation. We are up and running again. Nice. The developers, in the meanwhile, they are solving the bug. And we have the application which is still up and running, even it's a little bit buggy. So let's say this problem can happen again, and maybe, maybe another application is failing, and then it's restarted. But anyway, it's better than be completely down, And we can have our developer team working, let's say, on the bug. Of course, we want to release a lot of features, We are an evolving startup. We want to release features as fast as possible. So we need, let's say, to release new versions of our, let's say, software as soon as possible. And Kubernetes is also helping us doing this kind of stuff. So let's say we have an app, and you can see on this slide, app is called, for instance, now Hello 2. Let's say we are coming from Hello app version 1, and we want to go to app version 2 with the nice new feature. On the left-hand side, you see our application running. I have a few instances, a few replicas, and you see we have 3 replicas. But I mean, we don't care how many. We just, to be resilient, we have multiple replicas of our application, maybe running in different cloud zones. This is handled by Kubernetes. Now we want to release the feature. So Kubernetes helps us slowly, let's say, not slowly, let's say gradually release the application as fast as possible, of course. And look at the animation now. So we shift the traffic from left to right. So I say to Kubernetes, I want the new version. Let's play it again. We are coming from here. All the application is version 1, and slowly we go to version 2. Within a few seconds, according to the application, could be 3-4 seconds, could be maybe 30 seconds, depends on the technology you're developing, depends on the programming language as well. But anyway, for us at the moment is about releasing the application in a gradual way without downtime. So let's say here in the middle, you have version 1 and 2 running at the same time. So of course the developer need to be aware of this, that for a few seconds, you have 2 versions of the application running. So in case there are some breaking changes, they need to handle it in a proper way. But what we need, let's say, the cloud and Kubernetes for, in this case, is for our point of view, is to release in a gradual way without downtime and as smooth as possible. And this is possible with Kubernetes. Nice. I'm already, so by the conclusions. So I think, so we had, let's say, a nice summary, a nice journey about the cloud. And we have seen, let's say, going from the cloud to also the orchestration of containers. We had different steps, okay? We started from a few machines, we said. Then we are successful and we need something more. We need more automation, we need abstraction, and we introduced the concept of orchestrating applications and containers. Super nice, but in my opinion, and I have now, let's say, I'm in the industry since almost 12 years. So I have seen a lot of, let's say, situations, and I realized that actually, there are technical challenges, of course, but normally and we need to address the technical challenges. But the biggest ones, let's say, almost all the time, they're human challenges. Let's say people which does not maybe want to learn, or which is scared, or people, let's say, not communicating properly, blaming others. We have seen all this stuff. So in terms of, let's say, managing a technical environment, or maybe you are developing even in a technical environment, whatever your role is in a startup, what helps, but not just in a startup, actually, in every company, what really helps, in my opinion, is to have a really, let's say, friendly, open, blameless culture where we know that we can make mistakes. We try to avoid as much as possible make mistakes. But we make mistakes, we are humans. And the most important part is to learn fast from those mistakes and not making them again. So it's nice if we are in a team where we don't say, yeah, he is the one, she is the one who made the mistake. We should, let's say, cooperate in an open way and trying to have, let's say, open, blameless culture with honest communication. Honest communication means sometimes give also, let's say, some critical or not so pleasant feedback. We should do that, of course, in a respectful way, but we need to, let's say, we don't need to hide things. I have seen that in different companies where people were scared about giving feedback, you know, and they were maybe just criticizing each other on the back, you know, without speaking openly. So this was a problem normally. And what I love also, and what I suggest, so is to be always open to, let's say, learn. It's not every, let's say, job, every company, every project. It's always about continuously learning. Let's say when I finished studying at the university, Kubernetes didn't exist, for instance. I finished my studies in 2011. So in Switzerland at the technical university. And I mean, I needed to learn Kubernetes 4 or 5 years ago. So I mean, and I love it, okay? So it's about continuously learning from the business perspective, also how to maybe to handle a new situation with a project, with a customer, and also from the technical perspective. And of course, last but not the least, in my opinion, is also about sharing knowledge. This is what, let's say, today I'm doing here for the people here and for the people online. So I am aware, let's say, I'm not the best developer in the world or the best expert in Kubernetes. I have some good experience. I can, and let's say, I achieved good results with the customers and with the projects, of course. But let's say, even though I'm not the best, I love to share knowledge, let's say, because sharing, it's really important. And that's also so why we are here today. Nice. Okay, so just to finish and to recap, you know, what have we seen today? By the way, at the bottom of this slide, you see the link to download these slides, you know, the bit.ly/, slides, i.e. Kubernetes, so K8s. You can maybe take a screenshot or take a picture. Once you have the slides, you have, of course, also the link to my website in case you want to have a look or get in touch, you know, just give me some feedback. So the recap is, so we started about defining a startup and the cloud. Then we have seen how actually the cloud can help, you know, if we are the founders, if we are co-founders, let's say, of a startup, or maybe some, let's say, person working in the startup. What are the benefits and what are potential challenges as we are growing, as we are scaling, you know? And in terms of technical challenges which brought us to automation, to orchestration of, let's say, of applications. So basically orchestration of containers. Then we reminded that after that, we don't just have technical challenges, so we have also human challenges, and how, let's say, what are some, of course, of the best practices to overcome, let's say, these challenges. Cool. So I think, yeah, we are done, and I thank you all for the attention. Now there is a little present. So you have like the free, let's say, slim version of my ebook. So if you take a picture here, you will be redirected to a small form with 2 fields. You can, if you want the book, of course, feel free to share it also with some colleagues, some, family members, whatever. So you can register in a landing page. Let me know if it works. So if, resiliency with Kubernetes then is working well also with my app. Nice. So there, basically, you just register, and within a few days, I will send you the link to the PDF with my email automation tool. So yeah, thank you. And yeah, if you have any questions, so feel free now to ask. So I'm open also for questions, let's say online. Maybe I need just some help from you, like for reading that out. So feel free to start.
Yeah, first of all, thank you. It was really useful. I wanted to ask, what are the best tools to monitor Kubernetes? Because we talk about deployments, but what are the best tools in order to monitor what's happening under the hood?
So, monitoring. I have, a background, of course, in open source, because I have been, and I'm basically still working with Red Hat. And from the open source perspective, we have the tools like Prometheus and Grafana. So I don't know if you have heard about these tools. So Prometheus is basically a time series database, which is collecting information about your systems. So your applications need to be designed, of course, to be cloud native. So they need to expose endpoints, let's say, normally using HTTP. And Prometheus then is scraping, collecting information from those applications. Then you need to visualize the information, and to visualize, normally you have Grafana. But of course, they are the open source way. These are the most famous. There are different ones, but let's say more than 3/4 of the monitoring stacks are using Prometheus and Grafana. Then, of course, you have cloud-specific, let's say, technology. Like, for instance, on Google Cloud, you have the Stackdriver suite, and for logging and monitoring, which is nice, but I have mostly experience with the open source way. I think you had another question.
Yeah, related to the question before, have you ever used InfluxDB, which is like the mix of the two open source technologies? And also, 2 years ago, I was working for a startup, and they had a monolithic architecture, and I explained why you're not using microservices and all these things. And they told me they want to create the domain knowledge, and from the domain knowledge, they will build the different Dockers and microservices.
So let's start with the first part. So InfluxDB, I know basics, but I don't have operational experience. So I think it's a nice alternative. I personally didn't use it. I just studied a little bit, just a few blog articles. But I think it's a really nice solution. Some customers actually are using Influx. But it's more, let's say, the market leader, let's say, at the moment is Prometheus with Grafana, but Influx is a good alternative that makes sense. So for the second part, it's really interesting. It's a really interesting question. I really like it because it happens really often. And I think it could be, if with the right approach, could be a nice idea. So since we are building, let's say, a startup, we hope and we do our best to be successful, but we are not 100% sure. So basically, building the domain knowledge is really important. I think that's actually most important part. And let's say, if we are technology experts and or ourselves or cooperating with them, it's important to build together the domain knowledge. So if we need to start with let's say, a single monolithic application to do that, I think it's a good idea because microservices are, I mean, they provide a lot of advantages, let's say in terms of scaling, in terms of speed of deployments, but they are not easy. So if you cannot build from the technical perspective, and if, let's say, if you don't have the right domain knowledge, and if you don't have the technical knowledge, actually it's using microservices is a disaster because you are not normally, I have seen some pictures and they said, if you cannot build a monolithic crap, how can you build a lot of small crabs, you know, which need to communicate with each other over the network, which can fail as well. So actually, if you don't have the domain knowledge, it's worse, let's say, to use microservices. So I think it's really nice, but there is one thing to watch out. Building a monolithic application, it's easier from the operational perspective at the beginning, but then it gets a mess if you don't use the right programming best practices, like using modular design, writing tests, automated tests, trying to, you know, have a clean design. So sometimes we have this so-called like spaghetti code, a mess, you know, and when the monolith gets really big, that's why it's called a monolith, it's impossible to make changes. And then you are in trouble because you cannot evolve anymore. So of course you need to watch out for those things. So another question.
Thank you. When would you use a container service or a container orchestration service like Kubernetes versus an auto-scaling service, for instance, with EC2 instances or with virtual machines? What's the right use case for each one?
So in terms of tools, I think you need more something like a platform. So like platform as a service. For instance, yeah, Amazon, of course, has the offering, Google as well, like with the Google App Engine, for instance. And I think it depends on the skills, let's say, of your team. So, and of course, let's say also your skills. Basically, if you want more control and you have a skilled team, it's probably better to have like Kubernetes because you have more fine-grained control. If you are, let's say, if you don't have so much knowledge, it's better to go up in the pyramid. So if I just go back some slides, you remember I showed the pyramid. And what you are saying basically is going upwards. Let's say like platforms as a service or even functions as a service. So you go up the pyramid if you don't have a lot of technical skills, you know, for the beginning, for experimenting. This makes sense. Of course, you need to keep in mind the trade-off with the pricing as well, because it's not the same. But I think it's also a good alternative, actually. So to use, let's say, something even more high level than Kubernetes, because Kubernetes also has some learning curve. So if you don't know, let's say, Kubernetes, maybe you just know how to write some code in Python or Node. Let's say you have a Node.js application and you just, you know, want to write 10, 20 lines of code, deploy, just run it in the cloud without thinking about the configuration of Kubernetes, then I think it's a good alternative as well. And normally, actually, the best solution, the real world solution, is a mix of them. Yeah. So, another.
Yeah, so thank you very much for your intervention. And I just had a question more regarding the timing. So when you put yourself in the shoes of an entrepreneur, let's say, as you just mentioned, sometimes like all the solutions that are not Kubernetes are really functional. So when would an entrepreneur know when is the best timing for him to switch directly to such technology?
I think this is a really interesting question for which it's a bit hard, I think, to give an answer because it's normally a matter of experience. So of course, it's difficult to catch the right time. So normally, of course, it depends on the experience or again, of probably your technical leaders or CTO. So normally, I mean, you will try to experiment, you know, and when you realize you are struggling, you start the switch. So it's really difficult to say an exact timing, and it can change from company to company because maybe one company has more, let's say, junior developers, some other have high-skilled developers with maybe could even start directly from containers. So, I mean, it's normally a choice of your technical leaders. So in terms of phase, I cannot mention one in particular. So it's a matter of, I think, continuously monitoring your infrastructure and continuously monitoring how your team is working. If your team is struggling, you will see, for instance, if you are using some kind of tool, sometimes teams use, for instance, agile methodologies, and therefore maybe they use like to divide work in sprints, let's say, and they have tickets with some kind of estimation, let's say, and then you will see the team velocity. And so you sometimes at some point you will realize the velocity is going down, for instance, because you cannot keep up anymore. Could be, for instance, a right moment. Or maybe you see your monitoring. So we had a short, let's say, question about monitoring. Maybe you see that your infrastructure is not keeping up, let's say, and you want to scale faster. And basically you, from the Prometheus, for instance, Grafana tools or Stackdriver or the, I think AWS is CloudWatch, something like this. I'm mostly focused on Google Cloud. So basically you will see the monitoring is saying that, let's say, the CPU usage is always super high. And then you have to, let's say, ask your developers to provide new machines. And you will see that is happening maybe every day. So probably you start thinking about the auto scaling in that moment. So it's a matter of continuously evaluating and deciding according to several factors. So I believe it's like this. So are there like questions or maybe in the chat or otherwise? Yeah. Okay. So thank you again. And yeah, have a nice evening.